One application of inflection points is to find something that's referred to as the point of diminishing returns. We'll take a look at a sales function that represents the total sales revenue in thousands of dollars a company will earn after spending X thousand dollars on an advertising campaign. Find the inflection point and talk about how this relates to the idea of diminishing returns. In Symbolab, we'll use that same command. We want to find inflection points for this function, negative 0.0065 x cubed plus 0.0372 x squared plus 0.0079x plus 16.7646. We're given one of our values as a fraction with two decimal values and then a decimal approximation for the second result. We could use a calculator or Symbolab to convert that first value to just a decimal approximation, which would give us the inflection point occurring at approximately 1.9077, comma 16.8699. To talk about what this point represents, let's go back to that graph that we looked at and erase some of this information that we drew. So this isn't a graph of the function that we're dealing with in example 3, but it's a good visualization of the concept. What we found was this inflection point, which we're going to call the point of diminishing returns. Because again, what's happening at this inflection point is that our function is still increasing, but that rate of growth was more rapid up to that inflection point. And then after that inflection point, while our function is still increasing, function values are still getting larger, that rate of growth starts to slow down. So we still see growth, but at a less rapid rate after we cross that inflection point. What that means in the context of this problem is that our company will earn, in this case, $16,869.90 because we need to update this value since this is total sales revenue in thousands of dollars. And we'll also have to update our X value since that's representing X $1,000. So once we make those unit conversions, we'll see that our company will earn $16,869.90 in sales revenue after spending $1,907.70 on advertising. So that's the implication of those X and Y coordinates. And then since this is the point of diminishing returns, that means if they continue to spend more money on this campaign, sales will start growing at a slower rate. That is, they could continue to spend more money on this advertising campaign. If they do that, they will continue to increase the revenue that's coming in, but the gains on that expenditure will start to get smaller. It's up to this expenditure of $1,907.70 where they're seeing the most return on that investment. They're getting the most increase in revenue based off what they're spending. We can still continue to get more revenue, but we're spending more money per increase in dollars of revenue. So that's what we're talking about with this point of diminishing returns. The revenue didn't start decreasing, it's just growing at a slower rate. In example 4, we could repeat this same process. We would end up getting an approximate inflection point of 2.2971, comma 28,485.89. We're told that this function represents n units of a product after spending X $1,000 on advertising. So we'll need to multiply our X value by 1,000 for the interpretation. This point is telling us that the company will sell 2,297 units after they spend $28,485.89 on advertising. And then again, they could continue to spend more on this campaign. The number of units sold will continue to increase after that, but the number of units sold will start growing at a slower pace. Again, giving us less return on that advertising investment. Similarly, in example 5, actually a little bit different here. Let's go to Symbolab and enter this information in because we're going to get slightly different results here. We're going to get multiple results. So we want to find inflection points for negative 0.2193 x to the fourth plus 5.9277 x cubed and we get two results, 0, 0, and this, not quite a fraction because it's made with decimal values, but this non-zero 0 point. If we go back and look at the original problem, we didn't really focus on this, but this was stated in each of the problems. This model that we're given is true on a specific domain. In this case, for values of x between 0 and 20, including 20 but not including 0. So while 0, 0 is technically an inflection point for the function, it's not an inflection point that we want to consider because it's outside the domain for this model. That means that the only inflection point we have will be at approximately 13.515, which we get from plugging that fraction, that sort of fraction value in and getting that decimal approximation, comma 7,316.5945. Both of these values are in hundreds, so X 100 new workers, and T, the value for T in hundreds, which is total number of units produced. So we need to update both values by multiplying by 100 to complete our interpretation. This tells us that the company will produce an additional 731,659 units after hiring 1,352 new workers. But if they continue to hire more workers while the number of units produced will continue to increase, again, the units produced will start growing at a slower rate. Units produced don't start decreasing, we just see a decrease in the rate at which they're growing.